Do we live in a simulation? And can we use simulations to give us some light on whether we live in a simulation or not? That's the question. When we look at this kind of code, we see it and perceive it as an object that gives us some sort of satisfaction, or can be seen as a resource that we can consume. But is this kind of code what reality is? Or is the reality that we don't perceive much more complex and out of our grasp? In a way, reality can be the same as a computer is, where we see a set of pixels with colors in the screen, but the reality that is behind that is all these electronics and transistors that produce electronic signals that allow us to see this beautiful screen with colors that makes our experience to use a computer better. Is this also happening in reality, where we only perceive the things that we need to perceive in order to survive? That is what we're going to talk about on this video. This video is based on Donald Hoffman's work. Donald Hoffman is a guy who became famous from a TED Talk many years ago, in which he explained the idea that we live in a reality in which we can only perceive the interface of it. He talks about a headset that we have on, and from a scientific standpoint, the only thing science is doing is studying this headset, which means that there is something beyond that that science has never touched. He rejects the idea of reductionism. So reductionism is the idea that to explain something very complicated, you need to go back into the most simple particle, and when you explain that, you can explain all the emergence of the universe. So he said that that's the wrong framework from a scientific standpoint. Now, this is complicated and we're not going to go through all this in detail, but we want to tackle one particular point, which is one of his studies related to veridical perception, and we will study if veridical perception, which means that seeing the truth, is beneficial for our survival from an evolutionary standpoint. So let's get started. Okay, so what are the evolutionary pressures on veridical perception? Is it better for any entity survival to not see the truth, but to see a limited truth? That's what we're going to investigate today, and we'll build a simulation to show this. But first, let's explain how we're going to tackle the problem. So we have some entities that live in a world, and in this world, they can find resources. These resources they consume, and they have better chances of survival if they consume more resources, as long as these resources are nutritional for them. This agent has a particular genome, which tells us what the actions are going to be based on a particular state of the world, and what is the agent able to see and perceive in this world. So there are three kinds that we will use. The first one is the world state action genome. This one defines what the world looks like in the north, east, south, and west and center of this agent in order for the agent to decide a strategy on what to do. So let's see what these actions are a bit later. But in general, the agent can have resources in a particular direction, and this will be defined by an array. In this case, in the north and east, we have food. In the south, we have nothing. In the west, we have a wall. And in the center, where the agent is positioned, there is nothing. And this comes up to be 243 possible combinations of food, nothing, and wall. The second genome is the utility color perception. So each resource has a particular nutritional value. And this can be defined from a utility standpoint as a non-monotonic function. This means that a nutritional value of 5 might have more utility for the living being than a nutritional value of 10. So this leads to the genome, which is the color perception. If it's a G, which means green, the agent will look at this nutritional value as something that is edible and good. If it's red, it will look at it as something that shouldn't be eaten, so bad. And the third one is the direction perception genome. So the agent looks into these four directions, and maybe this agent is only able to see to the north and to the south, and not to the other two directions. So that means that this leads to a genome of 1010, which is 1 to the north, 1 to the south, because it can see those, and 0 to the rest. There's 1 to the center, but we will assume that the agent can always see where. So what are the actions that the agent can perform? It can move to north, east, south, and west. It can move randomly. It can pick up food, or really try to pick up food, whether there is food or not in the position that he's in. And he can rotate right and left. So let's see, move to the north, east, south, west, then moving random, may end up going to the west, then pick up food, and if there's food in the center, he will pick up the food, and then rotate to the right or clockwise, which will change the direction that he can see, or rotate to the left. So we need to calculate a fitness function. Why is it better to do anything at all in this world? So we first give some utility for the collective resources. So if the agent eats something, then he gains some fitness, but he loses fitness if he tries to pick up some food, and also if he hits a wall. He also loses fitness depending on how much he sees. If the agent is capable of seeing in all directions, he will spend more energy per movement than if he is blind. So this is the other part of the fitness. To solve this, we can use artificial intelligence and reinforcing learning, but instead we're going to use the good old genetic algorithms. So this is the first generation of agents, and all the agents after they live their life can have offspring. So there's always a bigger option for the person with the biggest fitness to generate offspring, so he can mate with several people. So here we see that the person with fitness 20 reproduces a lot, while the person who has a fitness of -15 doesn't reproduce at all. So we can go through all this generation by generation until you reach a point in which you can see someone who takes the right actions and perceives the world as it should be perceived. So the question is, how is the stronger person perceiving the world? Is he blind or not? What kind of actions he performs based on different conditions of the world? That's what we want to answer. So here is a simulation that will help us answer these questions. And here in the top left, you have the world in which the agent lives in, that has different resources with different numbers that constitute the nutritional value for this particular resource. They are green if the agent feels that the resource is useful, and red if the agent feels that the resource is not useful. So here we have the visualization of the whole world, but we can see at agent level in which we see what the agent sees as he moves around the world. So for example, here in red are the sites that the agent cannot see, and in green the sites that it can see. So in this particular position, it only sees this resource, which has 0 nutritional value, and it's also red, which means that it has no value for this agent. On the top right, we have all the information related to the genetic algorithms. We have the pickup cost, which is how much does it cost to attempt to pick up some food. The wall hit cost, how much does it take to hit a wall if you go towards the direction in which the wall is, and the cost of perceiving the world. So how much does it cost to observe to different directions? Also, we have other things like the number of generations, population per generation, and different things that allow us to initialize the genetic algorithms in different ways. On the bottom right, we save the best specimen that we ever got in all generations with all its characteristics and genome. So let's make some runs to see what happens. On this example, we chose a pickup cost of 2 and a very low cost to hit the wall. And we can see on the bottom left how the average fitness increases as generations are created. So on the bottom right, we see the best specimen ever, and we can see that considering that the pickup cost is 2, it only sees the resources that have an utility of 3 and more, only the middle ones. The extremes that have an utility of 0 and 1, the agent doesn't even know that they are there. And here on the top right of the best specimen section, we see the sites that this agent can see. And it's clear that it's not necessary for the agent to see all 4 sites. With 3, it's enough to balance between the cost and the rewards that an agent can have by having more senses or more perception of its surroundings. Now, before explaining the rest of the section, let's see what happens when we use a high pickup cost of 7 while having a really high cost to hit the walls and almost no cost for veridical perception or for perception in general. In this case, the best specimen has the ability to only see the resources that have an utility of 9 and 10, making the other ones invisible to him. On the other hand, it has the ability to see everywhere because there's almost no cost in energy to see all its surroundings. Now, if we see the lower section, you can see into different states and what would be the action in each one of the states. If we see the one on the bottom left, the agent will be on a red spot, which means there's no food where it is, and there's food at south and to the west. And the decision in that case would be for this agent to move south, which is a great decision because the agent can find food there. Now we can click on this Generate World button that will create new random situations that the agent can find himself in, and we can see different situations and the decision that the agent would have in these different scenarios or world states. But we're not going to go too deep into this, and the simulation will be available online if you want to try it out, and I will leave the link in the description, and there you will be able to have fun playing with it. So what we have seen in this study is that natural selection doesn't favor truth at all, unless truth comes at 0 cost, which means there's no energy associated to perceiving the truth of the world. Instead, natural selection favors utility, which means that for a species to be successful and to thrive on this world, it needs to be very aware on what gives high utility, and not so much on whether something is true or not. And this is something that we can think about.